All right, welcome everybody to the April 7th edition of the KubeVirt SIG storage meeting. We're just getting started here. First agenda item is to review the 1.6 virtualization enhancement proposals that might have implications for storage. So we'll do that. This is a new process, but it would be good for us to take a peek at those in here. Um, And then you guys can feel free to add your other agenda items as we go. So obviously, we all are familiar with the topmost one from Alexander. So we can pop that one open. I guess we should probably just talk about the ones, like we should look at each of these, see if they have storage implications. For the ones that do, when we're lucky enough to have the author here, we can talk about them. Otherwise, figure out where they need to go from our SIG's perspective. So, Alexander, how's this VEP doing?
It's pretty good. I almost have it approved. Um, so yeah, it's just moving along. It's going through the process.
Okay. So it basically, I guess anybody who wants to look who hasn't already is of course more than welcome to. Any major issues with it that are undecided at this moment, or?
Well, this morning there were a bunch of comments by some people that I need to address. But other than that, I've got all the major maintainers on board already. So
Okay. Well, that's good. Then we can move on. This one is in, I think, pretty good shape. Um, okay, next is IBM Z secure execution. I'm guessing that doesn't have a ton to do with storage, although maybe it does. So maybe I should click that. How do I open this actually? Come on. I think I can. No, you can't.
Adam, there's a column on that sheet that says what SIG owns it.
Oh,
You
thanks.
scroll if you scroll over.
Oh,
What we've had, yeah.
if I could move that over here, that would be handier. Thanks, Michael.
Should this link be accessible for everyone? Because I get 404 error when I click the link from the document.
There was this one down here, the VEP tracker is the one
Yeah.
I clicked, the 1.6 VEP tracker.
Yeah, do I need some special permissions for that, or is it open for everyone?
That's a good question. I don't think
I see a lock near the KubeVirt 1.
Yeah, I think it's still private.
Oh, well, that would be something we should. I'm gonna mark that in here because I don't. Maybe it's something to do with like edits or something, but okay, thanks. Well, that's helpful. So we can kind of skip. I mean, I'd hate to, I guess Michael, are you aware, is there like some kind of review process that's putting the SIG labels on, or are people doing that themselves? Like if they want our attention.
This sheet is like computed based on fields that are set in the corresponding VEP issue.
Okay.
So pretty sure that's how it works. Actually, no, wait, there's a plus down there. But a lot of the tags and stuff, but yeah, they are still they're manually added, but all the fields like in the columns are populated from fields in the issue.
Okay, because like I'm looking, for me, I feel like the only thing I don't want to do is miss an issue where we think like, oh, somebody from storage should look at it. Like for example, VEP16 use image volume to mount OCI images as volumes in Vert Launcher. Like that seems like somebody from storage ought to at least take a look at it and confirm.
Yeah. So then if yeah, so yeah, I guess then yeah, the label should be go in the issue then.
Like we could just, I think what we should do is look like they're the responsible SIG, but I wonder if we should like label storage on this one just so that we can. I'm just
Yeah,
I
I think
haven't
you can
had
just add /sig storage if you want.
and it might be nice to see like yeah if somebody wants to take a look like maybe Alex or Alexander or somebody just to kind of like review it cursorily and see.
I can take this one.
Okay.
Yeah, it is. We are going a little backwards, but yeah, I guess we're learning. Like basically, this label should be ideally, I think, in the issue before they're added to the tracker.
Yeah, I mean, I think this is going to happen. Like sometimes, and people aren't going to think about storage. Like I think when a good example of that is when we did the persistent TPM stuff. Like at first, the compute team started looking at that, and they went and ran with it, and then later on, SIG storage kind of saw like there's probably some pretty good storage aspects to how we're doing this, and so yeah, I just want to try to try to avoid that in the future. Like if we can get involved early, we can help with a design that's going to save everybody time, I think. So um yeah, DRA I think is
But I think the process is like all the SIGs have to like approve a VEP. Um,
mhm.
so yeah, I think even if the labels are not explicitly there, I think all the SIGs have to approve one.
Okay.
Yeah,
Approve it.
you're right about the array. There's a SIG storage integration point in block volume hot plug. I voiced my concerns there. I think before it was a VEP, when they're using like this old method of proposals,
Mhm.
and I thought it's gonna end up in the document, but I never followed up. Yeah, it should have SIG storage for sure. It touches everyone really. Like there should be SIG network too.
So it should be /sig storage, not /label.
Okay. Yeah, I see we got I'll delete my erroneous comment. Some storage integrations. So can I just do this? We'll pick it up in the context of a.
Yeah, that's fine.
Cannot. Oh, what did I do wrong here? Am I just, am I supposed to do, what did I type wrong here?
Hmm.
That looks right.
Maybe
Label
the
sig
SIG
slash sig.
prefix. Maybe it takes the SIG prefix from the command itself.
I don't know if it'll react to, all right. We're all learning here, I guess. Let me just. There we go. So just SIG storage. All right. Okay. So incremental backup, we know, so we don't have Shelly here, but just calling out this one, very storage centric, also has implications for other SIGs, but we definitely own this one. I see, Michael, you've taken assignment of it. Do you have any, I mean, I guess it doesn't really matter. Everyone's looking at it. Comments are
Yeah,
happening.
yeah. Liche and I briefly chat. I don't know if she's on the call now, but yeah, there are definitely, I think, a lot of open issues with regards to the current proposal. Seems kind of, yeah. Basically, we'd like it a little more defined, some details figured out before committing to it, I think.
Yeah. Okay, that's fair. Yeah, I think we have a little more time with this one. We were hoping to maybe have some stuff in 1.6, but for something like this, that's going to get used by external vendors and it's an API we definitely want to have well thought out. Okay. So that one doesn't seem too relevant. Eviction strategy, node pressure eviction, probably not so. Nick hot plug. I guess the one thing that well, I guess we have declarative volume hot plug next, so let's open that one. I think Michael, I remember, yeah, you opened this. You want to give us a quick rundown on where we're at with it?
Yeah, I mean, I think it seems pretty straightforward. I think Liche reviewed it and maybe even LGTM'd it, but obviously still need other SIGs to review it.
Mm-hmm.
But
Okay, so this,
yeah, basically just allow for hot plug volumes by editing a VM YAML, and also included in that, kind of implicitly with declarative volume hot plug, is the ability to inject and eject CD-ROMs declaratively.
mm-hmm. And this, well, I'll read the cap. I don't know that we necessarily need to have a remedial class in what's already documented here. So I'm going to personally take a look at this, and I would encourage other folks who are here and or watching the recording to also look and weigh in if you have any suggestions. I'm guessing it's pretty standard if we're just adding the volumes and the disks sections, and that's allowed. Looks like we have oh yeah, we have the update strategy that we're using for that, kind of what we used for the storage migration.
Yeah, but yeah, it's but I think one of the big things there is that we want to allow for declarative volume hot plug, not just when the rollout strategy is live update, which is, and by doing that, that allows us to have the current sub-resource API use the declarative API instead of that. I don't know if you guys are familiar with how the sub-resource hot plug is implemented, but it will basically unify the implementation for hot plug. But
Some familiarity with that.
yeah, so yeah, it's I think it's a nice. I think it would be nice to combine that and kind of have a unified way of adding volumes. So anyway, yeah, take a look.
Do we have an eventual plan to deprecate the sub-resource API then at some point?
I don't know. I don't think we're. I don't know that we can really do that, but there is like a so the way the sub resource API works is it adds like there's a struct in the VM status called like volume requests. So when you do the sub resource API in the VM, it adds some fields to this volume request field, and then the VM controller reads that and then actually adds the volumes.
Mm-hmm.
So we're gonna deprecate that field in the status, but
Okay.
not the sub resource API itself. At least initially, I don't think that we're ever going to get rid of it. In fact, there may be we may be adding a lot of unrelated to this, but we're seeing a lot of like with VMware customers, they have these very fine grained access controls,
Mm-hmm.
and so giving like, you know, we may have sub resources that will allow people to just like add a CD-ROM, for example, or, you know, update. We don't want to give users permission to blanket edit any field in a VM, but just specific fields. And
Okay.
they do that
Mm-hmm.
through sub resources. So,
Okay. So they wouldn't, yeah, okay, that makes sense. Although it's interesting because a user, if they own the VM, you would think they would own the whole spec of it, but yeah, maybe
yeah, no.
Okay.
Yeah, there's some places where like there's a team that creates the VMs, and then there's another team that can like start and stop them and like, you know, add disks or something, but that's it.
Okay, so then you would give the I don't know if you call them the operations team, the more restricted team, you give them
Correct.
permission to manipulate the sub resource API only.
Yeah.
Okay, that'll be interesting to see how we like integrate that into the UI and things.
Yeah,
Eventually.
David Vossel is working on that.
Okay. All right, I understand it and sounds interesting. Great. Okay, so any other questions on or comments from anybody that's here on declarative disk hot plug? And this is for disks and CD-ROMs, basically any volume eventually. I know you mentioned a couple of times CD-ROMs, that's an understandable use case, but for I guess unifying all of hot plug to work that
Yeah,
way.
but basically any volume that is type persistent volume claim or data volume.
Mhm.
Obviously, you can't hot plug container disks or any other
Right.
volume types, but
Mm-hmm. All right, makes sense. Okay, and then let's move on then. So we have the 64-bit PCI hole. That sounds pretty compute centric, as does the video configuration. Doesn't seem to be much for us. So I think the ones that we talked about, which is the image volume and DRA, I guess, yeah, this one has SIG storage. If you think it's warranted, Alex, then go ahead and mark our SIG on this one as well.
Yep.
And I think that constitutes a full review of the VEPs under consideration. I guess we're past like VEP freeze now, so we wouldn't expect any new ones to come in. Cool. All right. I'll close this and then let's go back to the, we have some other topics. So the next topic is yours, Alex, block sparseness.
Right. So I have a link there, clickable. Right. So QEMU image lets you specify a flag called target is 0 to prevent it from writing every block in the target volume, or block volumes, that is. And obviously we want to use it, but so when you use it, you kind of declare that that this is a new block volume, so the blocks should be zeroed.
Mm-hmm.
And otherwise, like I don't know exactly what would happen, what the consequence will be, but you probably don't want to invoke it when it's not guaranteed to you. So there's this command, blk discard 0 out, and then you just pass it the path.
Mhm.
But I'm a bit concerned about it at scale. Kind of presenting it on behalf of Noam here, but it does take a couple of seconds in his tests. Like I guess what I'm asking is whether we could, in our unique position with CDI, just get this promise that this is always the case, that the device is zeroed out,
Mhm.
and it would make our lives so much better, and we don't have to worry about a potential performance regression.
Mhm.
But I understand that there's some risk here with static provisioning specifically. Static
Yeah.
provisioning, who knows? Like who knows what you get in that PV? Like if somebody wipes it or not. Like I'm sure there's a corner case, but
So I have a thought on that. Like I think we can tell like if um can we tell if it's no, I guess because you can have a statically provisioned storage class, but then it wouldn't have a provisioner string, right? So like I guess my question would be is could we reach out to SIG storage and ask like I guess the question that I have is, yeah, does Kubernetes prescribe in the dynamic provisioning API that when a CSI driver provisions a block device, that the block device is considered zeroed? I don't know if it guarantees that or not. I know that they used to have back in the really old days, they had a policy in the PV about that when you stop using it, that it should be zeroed. And I think they abandoned that because it's not something that they considered safe enough to rely on. Like that you can't really trust that it actually was zeroed. So they didn't want to put it in the Kubernetes API. So I'm just kind of wondering, in this case, if we're saying on the provisioning side, if I dynamically provision a block device, can I assume that it's zeroed? And generally, I would say this should be the case. We could say that for essentially if we recognize the provisioner string, or if it has a provisioner string, that maybe we like I'm wondering in my mind if we can, yeah, if we can detect that the volume was dynamically provisioned and it's a block device, we assume that it's already zeroed, which is exactly your question. But I'm just trying to figure out if there's a way we can, like, if we want
yeah.
to,
Yeah.
yeah, because for static, you're right. I think for static, we would want to call the zeroing function.
Yeah.
And I guess what you're saying is this is to replace, yeah, if we want to use the target as zeroed option in QEMU, which will dramatically speed up um, the provisioning in most cases. Yeah, okay.
Yeah, and with some backend block drivers, it also lowers the usage. Just at
Mhm.
least at the initial VM starting point. Obviously, later on you'll probably write everything out and it fills out. But you can see in the example here, only 2 gigs should be used out of the 10.
And I think in general, if you were to have a block device that had random data on it and you create a partition table on it and you format file systems, the file system, I think, generally can handle when this happens. I think the main risk of doing this is that somebody exploits it to read whatever was on there before. So somebody like provisions a volume and does that. But what I'm trying to get to is if storage behaves that way, you could exploit that with a pod. You don't need a virtual machine and CDI and everything else, right? If you dynamically provision a block volume and they give you somebody's old volume with like super secret data still on it, as a pod workload, I'd just write a pod that goes and attaches to that volume and scrapes off that data to some application, that forensic application that knows how to process it, right?
Yeah.
So I would say that if storage is doing that, the security issue is in storage. Now we might be papering over it by doing by writing zeros, but like we're not fixing, like it's not, they shouldn't rely on us zeroing the data in order to have a secure system, right? Does my argument make sense?
Yeah, to me,
I
this
think,
seems like a storage, low level storage thing, not necessarily our concern.
Yeah, so we can say that we expect the device to be zeroed. And if for whatever reason it's not, we're not exposing any new security problem by doing this. Because it would be exploitable by a regular pod as well.
yeah. Okay.
So in my mind, I would say that this is okay, but I think for any
Is that,
like,
yeah,
go
is that
ahead.
the only consequence? Like, don't you think the error that comes back from whatever was on there, like as you mentioned, like a partition or file system, wouldn't that be like a headache if we ever get a customer with some type of storage that I don't know somehow didn't come pre-zeroed? Like if Michael, if you remember, there was that fallocate failing storage, GCP or whatever. And like at the beginning, it's not zeroed or it is zeroed. I can't remember, but then later on, it complies to whatever we used to. But just the beginning was a bit weird, so you had to like zero it out explicitly. I'm
In
just
my,
wondering, yeah,
I mean, I think if you crafted data onto a PV very specifically, that would like my understanding of file systems, right? They have their metadata blocks that has it maps to the I nodes and the D nodes and everything that are stored somewhere. If you understood file systems well enough, you might be able to do something here that would confuse the file system and get it to. But I think first of all, you'd have to be very clever with how you put the data on the device. And the consequence for that really is only that like your particular VM that you own like has a weird file system behavior. Like I don't, but even then I think that like the file system is going to initialize when you create a brand new file system on there, it's going to initialize its own metadata. And I can't, I mean, I don't understand it well enough to be able to craft an exploit, but I think it would be pretty hard because I don't think the file system initializes itself, and it probably doesn't just blindly trust data that's on the device. It probably indexes through its own tables to locate blocks and its own metadata and things like that. So I don't know. I can't.
yeah. No, I'm less
So,
concerned about the exploiting. I'm more
Mhm,
concerned about an eternal failure with some, hard to understand message that never
mhm,
converges. That's what I'm mostly uh, worrying
mhm.
about.
I wonder. So for pre-allocation, if we have a data volume that uses pre-allocation, are we going to still do well, we would call the zero out command then, I guess, right? Regardless. But if pre-allocation is actually with pre-allocation, you wouldn't call zero out, you'd actually write the data, wouldn't you?
Yeah.
So that would be a workaround if we ever encounter like weird storage, at least. It would be something that could mitigate it in that moment for the customer while we reevaluate whether this was a good choice.
Okay. Okay, so okay, got you.
I think this is, I mean, I think this is a really good potential win, and the potential for bad stuff is, I think
Yeah,
we've kind of addressed the two sides of it, like that it should be a storage issue if it's not doing it, and that we can mitigate it on our end with pre-allocation.
right.
But it would be good to capture a bit of this discussion in the PR that turns this on.
Yeah, I'll try to summarize this in the issue. Noam is kind of waiting for the blessing to make the PR. I think it's stashed somewhere in a branch on his
Mhm.
local fork.
Yeah, I mean, I'd hate to have like I'd hate to need like a storage profile override, but that would be the, you know, if we did wind up with problems in the future where there's storage that we don't trust to zero properly, we have that escape hatch if we need to add
Yeah,
a new option there. But those are difficult to manage. We don't want to have a million different options in the storage profiles if we can avoid it.
yeah. Michael, I interrupted you earlier. Oh, okay. See you.
Okay.
Okay, I'll summarize this discussion there.
I have to drop. I don't know if anyone has anything quick for me before I go, but yeah. Otherwise,
Maybe we
yeah.
want to maybe Arnon wants to just pop this topic in, and Michael, if you have any thoughts on it before you go.
Okay.
Can you hear me?
Yep.
Okay, so recently I was dealing with several storage providers and testing with our T1 gating tests. We found some inconsistencies, which makes it quite hard to, to decide whether a storage provider is working correctly or not. We found, for example, as we know, different minimal sizes for PVCs and different handling of data volumes on PVCs, which are defined with smaller volumes. For example, some of them some of them increase the size and provision the PVC. Some of them keep the PVC pending forever with an event. Some of them limit the size. For example, it must be gigabyte only, and so on. This one, for example, breaks our file system override calculation because we want to get to a 1024 sizes. So we were thinking together with Dan Kingsberg, maybe we should extend a bit our storage profile to support such specific provisioners with regards to minimal size, quite similar to the way that Alvaro's KubeVirt PR worked. For example, a provisioner which is not supporting PVC smaller than 4 gigabyte, we will proactively increase the size to 4 gigabyte and so on. So from user perspective, the behavior will be more predictive, orthogonal to the storage provider. Any thoughts on it?
So let's give Michael a chance if he followed that. Oh, he had to drop actually.
No,
Oh no, he
I'm
didn't.
here. Yeah. I think problem is keeping this up to date. I don't know. I imagine this stuff will change. And if this, yeah, I
Storage
don't know.
by the way, storage capability change all the time. That's we're trying to to sync them with the vendors once in a
I
while.
guess this is probably yeah. I mean, I guess I'm not opposed to it in theory. I guess it just wonder how often in the real world using these really small PVCs for VM disks. But yeah, I don't know. I guess if
I don't like it either. It just
yeah.
Yeah.
For example, we see it on with Azure. Okay, that whatever size you define below 1 gigabyte is unsupported, and when you define the size between 1 gigabyte and 50 gigabyte, you get 50 gigabyte. Okay.
Mm-hmm.
Yeah. I mean, I think my it's just keeping it up to date is the biggest concern I have.
Yep. Tend to agree.
So I think it reminded me of a follow-up topic. I think we mostly hit this with TPM devices, but I mean 50 gigs is a pretty small floor or it's a pretty large floor for a PVC size, to be honest. I mean, I think our default images are smaller than that.
But with TPM, we don't use data volumes, right?
Right.
Yeah. Well, TPM, I have a whole thing here. It's a different one, and it's a problem that's actually going to get worse because we have 2 new use cases for using the VM state PVC. So I think what we're going to find is that over time, every VM is going to have a VM state PVC because it's going to be used for incremental backup. We also want to use it for syncing volume state from QEMU. So those are things that people are going to want to have whether or not they have TPM, and that is still a small PVC. So for VM disks, it's not as big of a deal if it just increases to 50 gigs. I mean, that's a reasonable size for a root disk. And the only reason I'm kind of somewhat preempting your topic is because I think that I wonder if the problem goes away for the VM state PVC, then do we need it in the storage profiles? Would we see it infrequently enough that it's no longer a problem? And that's why I think that issues are intertwined.
Yeah, that's a good point. If this is mostly an issue with creating the TPM PVC, then storage profile may not be, the place for it. I don't know.
Yeah. So I would say that
this is not only failing with TPMs, right? We've seen this when running or test with other providers, right? Or no?
Yeah, of course. Yeah. So we just providers.
And in my experience, the providers have been pretty against removing their limitations. Like we've been trying for them to remove the limitation, but it's always it's really hard to convince them. So
I get that. Sorry. It's just I just think that if the same problem exists for KubeVirt in creating their TPM devices and we have it here, then I don't know if there's some sort of common way we can solve it. I don't know. Because
we already look at the storage profile in KubeVirt, I think.
We do?
Right.
For the TPM, yeah, pretty sure.
Exactly.
Oh, okay.
We do for the access mode. So I just wanted to say that the Arnaud's proposal looks interesting. I will consider it.
Okay. Yeah. So is there a proposal somewhere?
No, we're just discussing it for the first time.
Okay.
Now. Okay.
Mm.
It's quite
Right.
straightforward, I guess, if we did to the storage profile, but we need to decide if it worth the effort, because for 99% of the provisioners, we won't use it to be just empty.
Well,
Mhm.
I mean, if KeyBird is using storage profiles now,
Okay.
and they need it for the TPM, then
Mhm.
we have to. It seems like something they have to do, right?
Yep.
I mean, I think just go ahead, Alex.
Yeah, I was gonna say that to me, these are all bugs in the provisioner, but just, there's a certain amount of time you want to waste that this problem exists in the world. So I understand where you're coming from. So you just want to tackle it in CDI, but really I think it's undisputable that it's an issue with the storage driver. Like all of these requests are legitimate, like customers are gonna do this, their customers are gonna do this. The different minimum supported PVC size. I'm sure somebody at some point outside of KubeVirt will find a reason to use a really small volume, and then the Azure driver would have to find some explanation to them why they can't do that. So, like, I get why we want to tackle it in CDI, but it's just adding more complexity, and we should, really try to convince them to fix it first. Like, just work well with everything.
So to me, if this
Actually,
was
we
just
tried.
so to me, like for resources that users create, like if this was just if TPM, if the issue didn't exist for TPMs, I would kind of be like, man, well, let's just show an alert and then users can adjust the size of their data volumes correctly. But because we create PVCs, clearly we have to be aware of this for the TPM stuff. So
Yeah,
we should handle it.
I think there's a bigger case for the minimum size one that like we just have that like Alvaro's trying to fix that with the annotation. If we had it in the storage profile that this provisioner is broken, you have to request at least one gigabyte or something. That one can be good. This idea that this size limitation one, like if I ask for 1.1 gigabytes and the provisioner gives me an error because they want my request to be rounded to exactly gigabytes, like that is an obvious bug in the provisioner. The Kubernetes API specifically states that that it should give you at least that, but it can give you more. I don't know, like that is a stupid limitation on a driver that we only accept exact gigabytes when the field is bytes, right? I mean, that you need to pass
Yeah,
in a rounded number, that's broken.
I agree with that. Yeah, for sure. But
I
yeah, just the
understand that.
minimums. Yeah, just the minimum stuff I think is the biggest concern, and I got to drop, unfortunately.
Yeah. Okay, thanks for being here, Michael. I think, yeah, and even the minimum size one, it's really dumb that they don't handle it. So, I mean, you guys are raising a good point about like, can we smooth it? But also, like, we got to be careful, and we've been pretty good at having provisioners fix their bugs. It's not hard for them to just like what we're arguing over is whether they take the request and round it up for us or they want us to round it up. Like honestly, that is the dumb argument. Like they should round it up. That's what Kubernetes says that they should do. And to make us know what to round it to for all the different providers is stupid. It's really that simple. If you ask me, and I know I hate to be like so hard on that point because it does hurt us, but like I don't understand, like why can't they add one line to their Golang code, and they're insisting that we add 1,000 lines to our code so that we can accommodate them and everyone else.
Yeah, and I'm coming to this from like the maintainer side, like why would you take in more code to maintain for no good reason? Like it's
I think you have a good reason because you either need to fight the storage vendors or have a simple and clean workaround, not workaround, but a clean way to solve it on a specific system, for example. You actually provide the user a way to overcome such behavior.
This is why I actually like the annotation to the storage class though, because then what we're saying is instead of enshrining it into our API, making it seem like a legitimate thing, we're saying this is a broken provisioner. It needs this annotation on the storage class in order to work with standard Kubernetes things. And so what we actually do with an annotation is we don't commit to saying, yeah, you guys are good, don't worry about this. We're saying you guys have an unsolved bug in your provisioner, and this is a workaround for your customers.
Yeah, I gravitate towards that too.
Yeah.
And I think
if we go with this in this direction, we don't provide any handling for the quantifier issue, right? We tell the storage provider that it must be fixed in his size, and until then, most of our paths are broken. Wherever you use storage API, it won't work until it's fixed in the storage provider side. Because we never provide fixed 1 gig quantas.
And also
Until
wanted to
then,
add
you
that
don't have a solution.
I wanted to add that regarding complexity, since we already have the storage profiles and we are using them on KubeVirt, I'm not seeing how adding a new field there would add that much complexity. I think we are already losing much time trying to convince the provisioners to remove their limitation and addressing the failures in the test and stuff like that. That maybe having the new field would end up being even more simple.
Yeah,
it will
that
also
is a
make it will also make our life much easier. For example, mine and Alvaro's, when trying to test, for example, a new storage provider. Okay, because you won't have to adapt it, for example, the tier 1 tests to that specific provider.
So I would suggest that we can still have both of these things, right? So if CDI maintainers think that this should be an annotation on the storage class, then there could be two annotations if you need them. There can be the minimum and the granularity. And we could respect those annotations within the CDI code. But in my view, these are provisioner bugs according to the Kubernetes API. They're choosing not to follow it. And we can provide a fix via annotations without polluting our API. And it's something that we could then drop more easily in the future. Like if we can drop an annotation and just stop like respecting it anymore when we don't think it's needed. But once we have a storage profile API and somebody actually adds something into the API, then we own that behavior forever.
Yeah, that's right.
So I would say from my perspective, and of course I'm not a CDI maintainer, but like I would say that the best way to do this is to start with annotations and see if that fixes it. Annotations can always be graduated to proper APIs in the storage profile later if we have a problem with the annotations. But I guess the difference with an annotation too is how does the annotation get there? Whereas with a storage profile, we put that in there automatically. But for like you guys are talking about Azure, for example, like maybe we could tell them when you create your storage classes, put these annotations on it. I don't know who creates the storage class in Azure. Is it us or is it Azure?
I don't have an answer.
And that could be something that even like if there are places that could be adapted to put it on there automatically if we decide we want it added automatically. Like we could put it on in, we could have the storage profile controller actually, well, no, I can't add it storage classes, but maybe HCO, whatever, but it could be in the instructions for setup. Like there's ways to do it.
Okay, but by the way, why are we preferring annotation on the storage class and not the storage profile?
I guess I don't have a huge preference, but on a storage class, that further implies that this storage is broken, not that CDI is broken. And I
Yeah,
think what we are,
yeah, sorry.
Okay.
Plus, if you do it on the storage class, whenever you deploy the cluster and you haven't deployed,
CDI, yeah, don't have
Kubernetes, you can
yeah.
say, hey, this is what we need, and then when you install it, it's all ready to go. So it
Yeah.
can be separated from the installation of CDI.
that's a
Okay.
good point.
One suggestion I have with this type of problems, if you really want to get like someone with experience let you know if this is like correct driver behavior, there's the OpenShift forum, and specifically there's an SIG storage maintainer from Kubernetes, Jan Safranek, and if you just ask these questions there, he has years of experience with misbehaving drivers. So we're only speculating about specific problems, and we don't really know, like we think we're the only use case for small volumes with TPM. Like you don't know that. You might they might hit million issues down the line with million OpenShift products. So I would check in forum OCP storage if this is expected driver behavior, like try to gauge how bad it is of a violation. It could be that it's so bad that it's basically not OpenShift supported, and we don't know that. So,
Sorry, and to further push that point, we should talk to the certification team. So Arnon, I know you have contacts still over there. If we expect a CSI driver in OpenShift to accept a non-gigabyte granular request, let's add it to the CSI certification suite. Like, why isn't it in there? Like we could actually tackle this problem at the OpenShift certification level, where if they want a driver, and that could put more pressure on them, because right now they maybe feel like they can bully one OpenShift operator into making a change because it's our bug. But if they suddenly can't pass CSI certification and I'm realizing this is a bit of a Red Hat topic, but like we can add it to the Kubernetes E2E test suite, which is the upstream version that says drivers should behave this way. And actually, I would push on that to assert that this is correct behavior in the Kubernetes CSI driver test suite, actually.
Yeah,
because I don't think.
Yeah, I used OpenShift because it was the Slack channel is for OpenShift, but really the experience there, they have experience with like drivers in the Kubernetes ecosystem. So
So yeah, I mean, I think if we want to say that a properly behaving CSI driver in Kubernetes rounds up your request to the smallest size it can support and whatever granularity it can support, which is clearly the intention of the API. This is why the API says you can be given a larger PV than you request. It's to permit the driver to do that. I don't know if Kubernetes says that it's okay to fail the request, but like I'm pretty sure the intent is that it should provide the best volume that it can given the request. Then we should have a test that ensures that it does that.
Okay.
So I feel pretty strongly about that point. All right.
I'll discuss it with them, no problem.
Sure. So we don't have enough time for my shared storage for TPM devices. I think I probably should just create a KubeVirt issue for it. I'll just, in case anyone's curious, I'll just say a couple words on it. We think that TPM devices are going to become the norm for all VMs, and essentially, especially in light of the problem that was just discussed, this could mean an extra 50 gigs of overhead per VM when all we really need is maybe 200 megabytes or less of storage. And it's an extra PVC for every VM that has to be managed. Some providers have limitations on how many PVCs they can actually provision. So this doubling the number for your standard VM is a pretty massive increase. And so I've started wondering about if there is a more efficient way to provision this VM state storage. I have two ideas. One would be to always configure, like to basically configure the KubeVirt host path provisioner on top of whatever existing storage is provided in the cluster with one super large PVC, and then just let all the VMs take their persistent state from HPP. That has some downsides, like no snapshot support, for example. But this is one approach. And then another approach was if you could, for example, have a KubeVirt would manage a shared VM state PVC per namespace per node that the VM would have its shared state on at any given time. That has other pretty bad downsides as well. But I'm looking for if anyone eventually, and right now I need to document the problem somewhere public where people can think about it. But if there is a way to sort of have collective storage space for these type of small resources, it would be really great. And improve our efficiency if we could do that. So it's something that we're probably going to have to face sooner or later. So heads up on that one. And with that, we are actually pretty much at time. This was a super full agenda today with some great discussions. So I'm happy that everybody joined and participated. I see some folks are dropping. Thank you all for joining. And we'll see you at the next one in 2 weeks.
Okay, thank you. Bye
Thank
bye.
you. Bye.
Thanks.
Bye-bye.
Bye-bye.